Quiet, it's early for me. Little, it's 9:30. Tell me about student life here. You guys stay up in the library until like midnight every night, or okay, good.
There's some times,
Like
but
sometimes, yes, you have to, but I've been some places where that's like all of the students do. You have dead eyes. You get decent grades, sure, but like they're dead inside. So okay, that's the point. Okay.
We need like the final situation.
Yeah, yeah, that's normal.
Yeah.
Yeah. Possibly IV drip and like the library. First part of the library, they let us like rent out these cubicles with, like by the semester. Very depressing. It's like this big, but man, it's so much fun.
like the little wooden desk when you're like on the
Well,
computer
yeah.
sets. But like if you get one by a window, you can just like look up and see something.
See, it's
but
too
I
distracting.
like that.
Yeah, if it's like I have 10 hours to finish the paper, but it's
No, something.
have no sunlight, exactly.
So yeah.
Oh, the long that's is for
That's even worse. Something about that is really sad.
Yeah.
We did a writing retreat this summer on Lake Biological Station. That was awesome because it was just like a cabin with nothing to do but write, and it's sort of like sitting on the porch of a cabin. Beautiful. I don't know if I told everybody this, but some of you I did. The up and down piece, right? They go through your history. It's like nice. So I've written a tiny little script here. You don't have to understand it, but I'll walk you through it. So we're going to be talking about for loops pretty soon. For some variable that I'm calling I, and anything that starts with capital A to Z and ends with whatever, do CD into that / biocomputing, and then do a git pull, and then CD minus is taking me back to my previous directory and done. So where I am, you'll see this is all of your repositories. I've cloned them all onto my computer. And so if I do that, it should go in each one at a time. You go into the biocomputing subdirectory, and then do a git pull. There. All right. So that is me getting your assignment 1 to grade. Woohoo! That's why I make you name things like specifically sometimes, so that I can just do it on it. But by the end of the semester, you also will be in this mindset of things must be named correctly or I lose my brain. Because once you start learning to automate, it's great. You're gonna have thousands of files that you have to deal with. Okay, so I've collected assignment 1. If I don't get anything from you in your repository, then no grade for that assignment. That's cool. I'll still give you feedback on it later. But let's try to do better next time. Quiz 1 will be at the start of next class. If you were comfortable with what you did on assignment 1, quiz 1 should be easy. You want the quizzes to be easy. Right? Okay. Any lingering questions about assignment one or anything that we've covered so far, things that are still kind of muddy in your head. Oh, thanks, yeah, okay. Okay. For now.
I saw it marked down as kind of annoying.
Okay,
That was like the only thing I feel like this doesn't look that clean on the terminal.
oh, it does not, it looks terrible on the terminal, but the whole point of it is that it's supposed to look kind of nice when it's rendered into a PDF or like on GitHub. That's the only point, is to look pretty. I'm honestly not too concerned how pretty your documentation looks. But it's a good practice to get into as you start, putting out job applications and stuff. Looking pretty actually does count a little bit, so. Okay. Yeah,
I was also curious, last class you said you never edit the thing directly.
yeah, okay. Don't edit directly in GitHub. The reason for that is because you can forget to do a git pull before you start working in Tune, and suddenly there's a conflict. So next time you go to push, you may have already encountered this, like you have unmerged conflicts and these weird error messages. That's because you like change your README online. So now when you go push any file, it's like no. And it just says no because it doesn't want to overwrite any changes that you made up there. So you have to do this complicated like conflict resolution, essentially. So it's not a deal breaker, but it makes it very annoying. In the first few times that happens, it takes like at least 30 minutes to get it fixed. Just avoid that. Hopefully by the end of today, we're gonna have 3 separate versions of your biocomputing. One will be on GitHub, one will be on your laptop, and one will be on the HPC. This will get a bit confusing because now there's 2 versions that you can work on a computer, and it feels like it's just your one computer because you're on your computer. But if you're actually logged into the HPC making changes on biocomputing, like uploading an assignment or whatever, push it to GitHub, and then you log out of the HPC, you're just at home working on something, you now got a different version of all your files. Unless you say git pull, like I listed on your repositories. So we're going to work on that being part of your workflow. And so I'll show you right here. I'm just going to say git pull. And I want to see already up to date. So that's the way you kind of start your day working in any terminal with a Git repository. It's just a quick sanity check of git pull. If you don't see already up to date, then you'll probably see made this addition, new file. That's also fine because that means it just brought it in from the last time you worked on it with a different computer. Okay. Well, we've got lesson 2 here. If you want to have this up on a side window or something, might be handy. But we're going to start out by kind of looking at the HPC. You've all got your accounts set up, so you're good to go. And here's my little diagram of what's going on. Here is the summer sun, right? It's confusing. There's a lot of moving parts. Okay. Yeah.
I had to use the HPC last semester for my machine learning class. Like, what is like what we're using? How is this like any different from like what you use for like the user for like neural networks and stuff like that?
So if you're doing machine learning and neural nets,
Yeah.
you're using GPUs,
Yeah.
not CPUs.
Okay, so it's like this.
So this is a CPU one that we're going to be on called Bora. There are different big clusters that we have access to. They all have their own name. Kuro is one that I use a lot, and it's got some GPUs on it. EMA and Astral. And so there's all these different ones. I'll show you the website. If you want to use GPUs, you'll have to log into a cluster that has GPUs. For this class, I was talking with the HPC managers and about the stuff we'd be doing, and they strongly recommend that we just all work in Bora. It's kind of the general use, best for learning what you're doing. Unless you already have code, you know how to run it. Help out?
Yeah.
Okay. So were you submitting jobs through like the Slurm scheduler and all that? No, okay.
It was really like you would use it like on, like, and then go to like the side cloud.
Yeah.
Like run the script and then it would be.
Okay, so you were using interactively.
Yeah.
Yes.
So it's like it was like a notebook and then
Yeah.
like it ran something, it's like 20 minutes, like it would.
Gotcha,
So
okay.
I was just like kind of wondering, so like I kind of.
Okay, so in that case, yeah, so if you're doing it for like a machine learning class,
Yeah.
you're probably gonna be using like a Jupyter notebook or something
Yeah.
like that. And you're running interactively, which means none of what I'm about to say here applies, but that's a very people don't do that in normal work practice because it's you gotta sit there for 20 minutes and wait. People do that in classrooms because it's easier to teach students how to use that. I think that's total horseshit, and I'm going to teach you how to do it correctly so that in real life you can like actually use an HPC. So what we're doing here is interacting with the HPC in the way it's intended to, where we can submit a job to it and then walk away, go get coffee or whatever. Bioinformatics is one of these fields that has these built-in like break periods, which is so great. It's like submit the job. Oh, I got nothing to do. It's just like I'll go to the beach for the afternoon. I'm still working. Kind of nice. And that's because we're submitting jobs. So we've got our local laptop here. That's what we call local. That's your computer. And the same terminal that you've been working on this whole time. We're going to always refer to that as local machine. When we log in to a cluster, we're not really logging into Bora or Kuro or Astral or EMA or these other big supercomputing clusters that we've got. We're just logging into this one little computer that we call a login node. And that's really the only thing that your computer is ever going to be talking to. So local only can talk to the login node. And the login node is for really small jobs. We're not going to ever submit like big bioinformatics pipelines on that. It's really just for us kind of playing around, doing the cd, ls, grep, these other commands that we're going to learn in here, totally fine. And we'll spend a lot of the class period just kind of using it as our personal Unix server that we can play with for small stuff. If you have a genome that you want to assemble, you don't get to do it on the login node. You can try, but it will raise a flag and the admins upstairs on the next floor will put you in timeout. Seriously, they like lock your account out or they throttle your access. And they're like, you're in jail for 30 minutes kind of thing, don't do this. That's all automated, but they see a report of that and they'll start getting to know like this username has made 5 errors this week, running jobs on the login node, they're gonna come after you. It's not nice. They're usually nice about it, but they also treat you like you're an idiot, and that never feels good. I know this. Yeah.
It's like stuff like on the login that you're allowed to do. Like, are you allowed to like do like a big poll?
Yeah,
on the login?
absolutely.
It's nothing like it's actually computational. Like nothing that's gonna like have to use a core or like a
Right. So they've got rules on there, and theirs is like anything that uses more than 12 cores for 30 minutes or longer gets you like kicked off. Nothing we do in the first half of this semester is gonna make it that far. Assembling a genome, yeah, you're screwed. You never get to do that on the login node. And the reason for this is like, I mean, this is a public supercomputer. And everyone's using it. People at VEMS are using it, students here, faculty here, researchers affiliated with William and Mary across the world are using this. So we're all trying to like use these same supercomputing resources, and there needs to be a fair way of saying who gets to do what. If everyone tried to run stuff on the login node, it would just crash, be chaos. So we're talking to the login node when we log in, and it can't actually even directly communicate with these big clusters. So if it wants to talk to the Bora cluster, it has to go through this workload manager called Slurm that then interfaces with that. We'll see what that is in a second. But the login can access these two resources, SCR10, which is your scratch space. It's like temporary files. It's a big storage drive. So it's scratch 10 and data 10, which is for long-term storage. And so on your local computer, you can upload files directly to scratch 10 and data 10 or download them straight from that. But those aren't places to run jobs either. They're just hard drives. They're just file storage. You want to run jobs, you've got to log into the login node. You've got to request some resources from Slurm, say, hey, I would like this much computing time with these many resources. I want this much memory, this many cores, and then here's my job. And Slurm looks at all the other jobs that people are submitting, and it puts you in line, and it runs your job when it's your turn. So you just get to submit it and walk away. When it's your turn, then it actually interfaces with Bora and runs your job. Now, Bora doesn't have any real storage space on it. These are just computing nodes. And so all your output files and, well, all your input files even are going to be over here in like Scratch. So you've got like your raw gene sequences here in Scratch 10. And you've got some script that's going to assemble them into chromosomes. And you ask for resources from Slurm. And then when it's your turn, it tells Bora, hey, we're going to run this job. Your files you're going to start with are here in Scratch 10. Okay. And you're going to get them, and then you're going to write them out to Scratch 10. So, questions about this kind of setup? Yes.
Is scratch then just like the short term memory?
Short term, I think it's 60 days here.
Okay. And it automatically.
It deletes, or at least gets flagged for deletion. And so if somebody else wants to store files and they need more room and you've got old files, you get deleted. If you've got like, you finally get your genome assembled and you're like, okay, I'm going to need this for more than 60 days, and you'll be playing with it. You move it from Scratch 10 to Data 10, and that's long-term storage. Long-term meaning until the admins decide you've had your fair share. If you've got 20 terabytes of stuff on there for 2 years, they may come emailing and say, it's time for you to buy your own external drive. You need to be a good citizen.
This might be a dumb question, but what is kind of like, if you put this, like your files into Scratch and storage, is that just so that you can send them later, or why would you just store them there?
Oh, okay. So Data 10 is long-term storage, but it's also got a really slow input-output read rate. And so if you're trying to run a genome assembly, that takes like a ton of, it bloats your files and you have all this like temporary file storage and it gets huge. That will slow it way down if you're going directly to Data 10. Scratch is really fast input output. So it reads and writes really quickly. And so it's really good for running your jobs. But then once your files are complete, then you're like, okay, transfer over. And so that's the main reason, is the speed.
Okay.
You throttling that speed doesn't just affect you, it actually slows down the whole computer, like the whole system. And so the admins request that you do all jobs to scratch 10, and then when you're happy with the output, move it to data 10. Yeah. And we'll see what that looks like when we start writing scripts and how to send it there, but it's just file paths. The login node is for light work. We're gonna go ahead and log in to the HPC now. So to do this, hopefully you've all downloaded Global Protect. If you haven't, Google Global Protect, William and Mary, and it'll get you the download. This does require like the Duo authentication or send to your phone. Who's got it already? You?
I don't think you need it, just if you're on Eduroam.
You're on Eduroam?
Yeah, if you're on the Eduroam Wi-Fi, I don't think you go for example, to connect to the PC.
Really?
Yeah.
Oh, I thought they were changing that. Anyway, I'm on Eduroam and it's been making me
Oh, for some, I can do get in on this.
hate Snake. Okay. Get used to using it because you're not always going to be on Eduroam. So I would recommend, even if you can get on, go ahead and download this, get it ready so that you can work from home also. Okay. So I'll give you a minute to get that set up if you haven't already. It's not too rough. Quick download, authenticate with Duo, and then you're golden. Here's my Global Protect. It's just saying, yeah, you're connected. Bigger. When you open it for the first time, it's going to ask you what portal. That's just gp.wm.edu. Yes,
Does it matter if I download the 32-bit or the 64?
64. Almost certainly, unless your laptop's like really old. Like before you were born. It's possible.
When do you go to like do the login? Like,
Oh,
like when
okay.
I like downloaded this
uh-huh.
and then like it's downloaded on my computer and then it's like this screen, but then this like doesn't take me to that, it takes me to the download.
If you do like command space bar and then search like global.
Yeah, global search for Global Protect. And then I had to keep doing that, so I stuck it on my little bar over here because I got tired of it.
And that's just like in five, like I just find it.
Yeah.
Okay.
Well, I'll go ahead and disconnect there. And I'm gonna try. Yeah, it's not letting me log in. It's just waiting. What's my magic get out of jail free? If something's waiting, Control C. Go to hell. Okay. So
So you just like click it and it's
yeah,
supposed to
you
open.
click it and it'll bring this up.
Yeah, I'm thinking of
It's not.
What's it bringing up?
It's not super anything.
It's not buggy, like, okay, recklessly, it's like a while, it's initialized.
Oh, okay.
Like if I go here and just like.
It's just waiting.
when
It's
you
just
go
like
to the install package, right?
Yeah, like it did all that, like I got this.
cool.
So
And so now you're clicking it and it's like just doing nothing.
yeah.
Yeah, it's really weird, it's like if you click on it and then like open it and then close it, and then like you're like, oh, it's connected then. And then like, it's so weird, I just keep on tapping it until it works sometimes.
Okay.
Do you still know about this?
Mm,
It's for me, I don't know.
oh, I see it like
Yeah,
get
that's it.
started.
So it is up there. Okay.
Okay. Ooh,
Yeah.
until
So I guess maybe this is like a Mac version of it.
yeah.
When you click it, it puts that little globe in the top. You got to click that. Okay. And then the portal is gp.wm.edu.
You're redirected to an embedded browser.
And now there's your browser, and then you sign in to William and Mary with your account. And it'll probably want to push a notification to your phone. At least the first time. Yeah.
What is the Google Pixel?
It's a virtual private network, VPN, and the point of it is to help ensure that anyone using the HPC has a limit in their account. It's like validated,
And then now it just, like I
secured.
like. For the deal, and then is it just like supposed to just like be like you're connected? Is there anything else we have to do?
Try the little globe thing again.
Yeah.
Well, that is very standard. Never mind. Okay, you're connected. The end.
So that's it.
You're set, yeah.
Okay. So then anytime we want to do it again, it's just like click this.
Click that and it will like bring it up automatically at this point, unless you want to change your portal, which you never will. So I'm just gonna click connect. And it's gonna open my browser. Say, hey, authentication complete. Great. Okay. So that's it. Okay, we all set there? So that security measures have been taken. Yay. Now, we're going to open our terminal. And we're going to type in SSH. This is secure shell. It's how we talk to another shell. Your terminal is actually called a shell, and so we're talking to another one securely. And then it's your William and Mary ID at bora.cyclone.wm.edu. No, your
Like your
email ID, yeah. Username. And say, do you trust this? Just type yes and hit enter. We'll be asking for your password also, which is a good thing. You won't be able to see as you type, so it actually is typing, it just looks like the cursor's not moving. It's hidden.
is it just your screen password?
Yeah.
Okay.
Yeah. You just press on.
Awesome. You're in. You're in. Beautiful.
Yeah, that's the only part of it.
Good. Good one. Awesome. Oh, we're all in. This was like the most painless classroom login to the HPC I've ever experienced. All right, now it's my turn. I'm gonna do it too. I'm kind of jealous. I'm just gonna type Bora because I'm special. I'm in. Okay. So this gives us some info right off the bat. We're logged in to the server Bora. And we're on the login node. And we've got 20 cores. What's a core? It's a separate computer. It's a CPU. We've got 20 of them available to us. How many cores does your laptop have? Really?
I don't know. MC.
You got the M2 chip?
Yeah.
You probably have 12 cores. That's pretty decent for a laptop. Again, I'm special because I have 32. Yeah, because I don't buy into the Mac
Oh, really?
hype. Yeah. I got myself System 76, so you get twice the computer for the same price. But yeah, 12 is respectable. 4 is like pretty common for a laptop. What this means is that for most tasks that we do, we can kind of spread a job out across the cores and they can each work on part of it simultaneously and then stitch it back together at the end. So if you have 4 cores, a lot of the stuff you can do goes 4 times as fast. You got 20 times. When we start actually working in Bora, we'll have different numbers of cores. And we'll have different memory. So yeah.
I got a thing after I got all, I have all what you have, but then the thing showed up that said that my connectivity was reset by here.
So are you logged out now?
Yeah, because I was logged in the same way you were, but then I was.
Okay. So you were pushed out for some reason, probably an internet drop. So try your up arrow, get your last thing, and you're just gonna have to log in again.
Okay.
Yeah. This time it probably isn't gonna ask you about the fingerprint and do you trust this connection. It's just gonna like let you in. Beautiful. And you can tell if you're in or not by your prompt here. Yeah. So this is saying you are Gzon at Bora.cycling.edu, and then there you go. All right, so that's our login node. We've got 64 gigs of memory. That's the RAM. Things that your computer can memorize and use. How much does your laptop have? Yeah, I'd be shocked if anyone had 64 gigs on a laptop. 8. Okay. What does this mean for like genomics and bioinformatics?
Well, if you have a different those and you're doing like sequence alignment, then like you're comparing with that by the sequence of everything else in that things. And you're getting all like the numbers and the stats for that. And so it's like super, it's like way too much information.
It's too much information that your computer can only. So Sophie, you got 8. It's okay. I honestly, like, here's the thing, a laptop, it doesn't matter because you can log into an HPC and suddenly you've got 128 or 64 on the login node. But on your laptop, there is no way ever possible, physically impossible for you to like assemble a genome or to do big sequence alignments because to align sequences, you've got to memorize them all. Like the computer has to have them all in its memory. And so if you've got more than 8 gigabytes of sequences, you will. You can't do it. It's just going to say memory limit exceeded, go away. Here on the login node, we've got 64 available, which is respectable, but not enough to assemble the genome. Now it's saying we've got some compute node information. And here's the names of the nodes, Bora 1, BO1 through 55. So we've got 55 nodes, separate computers. These are like, imagine physical boxes, like this is a server here. There's 55 of those sitting around in Bora. Each one of them has 20 cores and 128 gigabytes. So we could run jobs on those and expect to get that kind of resources. Now we've also got some other nodes on here, the HEMA cluster, HI 1 through 7. There's only 7 of these currently available to us. But they've got 32 cores, so 32 times as fast for a lot of things, and 256 gigabytes of memory. So we can do bigger jobs faster on those. And check this out. If you want to do GPU stuff for machine learning, AI work, neural nets, we've got HEMA 4, 5, and 7. They have a Tesla P100 PCIe, 16 gigabyte GPU, or B100. So depending on your resources, you look at this and say, what do I need? Well, is it available to me? This is just on Bora. If we get on here and go to Research Computing, WM, gonna say, all right, what do we got here? System architecture. That's what we're talking about here. How are these systems built? And the computing resources. Okay. Here at the main campus, the Cyclone. We've got Kuro. It's got 47 nodes. Each has 64 with 384 gig of memory. That's starting to get kind of respectable there. The Femto has 30 nodes with 96. Bora that we're using, 128, 55 of those. And then GPU resources, we've got Bora and HEMA. The Astral cluster. So we've got 512 gigs of memory on this one, 64, but that's only Astral 01, so only one of those nodes. Okay, so if you want to use that node, but somebody else does too, and you're both like, I definitely need 512 gigs RAM for this job, you might be waiting for them, their job to finish before yours gets run. So we wait in mind. Gust has exactly 2. Right, 256 cores, 512. You liking that one? This one is exciting. Okay, there's the resources for Gulf. And then here's the BIMS resources. We can run jobs on those, but the special BIMS people can kick us off. If they want to use that node and your job is running and it's been going for a day and a half, and it's like almost done, somebody at BIMS can come in and be like, no, it's mine. And they can start their job and yours immediately stops. It's canceled halfway through. Fail. Sometimes it's worth trying on a Sunday though. All right. So that can be kind of nice. So there's the BIMS resources. Again, we are logged into Bora, and so this is what we've got. Gives you some nice links on how to use this. Absolutely worth going through. There's tutorials, running jobs on Slurm, all that good stuff. Okay. And then the notice. This is the front end login service node intended for code development and cluster services only. All your parallel programs, you're requesting multiple cores, all serial computations requiring more than 30 seconds of CPU time, 128 gigs of memory, megs of memory, must be submitted through the Storm Dash system. Okay. As we're learning, this won't matter though. But in a month, we can start running pipelines. This matters. We can get kind of slap on the wrist and time out if we start doing things that require more resources. But here we are, we're logged in, and our laptop terminal is now actually a supercomputer login node. This is exciting. I had champagne and I popped cork right now. I don't know if that's allowed. Okay. So let's try out some of our commands. What are some things we know? LS. you should see data 10 and SCR 10. Anything else? Peak, brand new. Scratch 20, LSCR, we're not gonna bother with that. Okay. This is your home. How do I find out the absolute path to my home? Print that working directory. Now, it doesn't matter if you're on a Windows or a Mac computer. On your personal computer, Windows and Mac paths are very different. It starts like root C, that on Windows. On Macs, it just probably looks more like this. But now everyone should see the same sort of thing. Root, cyclone, home, Gzon. Well, you won't see the Gzon part, but your user ID. Who am I? Gzon. So there's another nice little Unix command. Fortunately, it tells us right here. So our prompt already has our name on it. ls-l. Let's list things long. We start to see some more information. So data 10 has an arrow. It's pointing to another path going on. The clue is right here. All right. This is our file information. D is for directory. Read, write, execute for the owner of that file or directory. The next three are read, write, execute for the group. The next three are for any other user. So what this is telling me is biocomputing is a directory, and the owner, me, because it says right here, if it's on the Gzon, I can read, write, and execute files from there. You cannot. You can't even read my files. It's saying no permissions. So that's a D for directory. L is for a link. Symbolic link. So this is kind of like an alias. Yeah, it's a shortcut. And so if I say CD data 10, tab complete, yeah, CD data 10, and then do PWD. Cyclone, home, Gzon, data 10. That's nice. But this is telling me that the actual path to it is different. Well, where's that actual path really pointing us? Yeah, it's a separate big box of hard drives called data 10 that actually lives within Cyclone. It looks like it lives within my home directory here, and I can access it through my home directory just fine using this path, but it doesn't really live there. This is symbolic link, and so they change the color, they give you the arrow, and they've got the L over here on the side. We look at our little confusing serial killer map of what's going on. It really is separate. So data 10 lives within Cyclone, but it's kind of like, it's its own thing within Cyclone. They're just giving us a really nice, convenient way to access it from our home directory, which is great. So I can say cd dot dot and go right back to my home. I can look around long ways again. And the same thing for Scratch 10, which we're going to be using a lot. It's also a symlink. Now, so far, that's all that you've got. Except it isn't, is it? There's hidden files. How do we show those?
ls space dash A.
Okay, whole bunch of crap showed up for me. You? Bunch more stuff. All these dot bash RC type things. Okay. They're hidden because they start with a dot. I'm curious if you all have the LL command. I bet you do. How about that? You got it now. Try this. Alias. Check out that line. LL equals, and then in quotes, LS dash AL capital SH, and then dash group directories first. So list everything. All, so hidden files, long ways. I don't know what the F means. H means human readable, and then group directories first. There they are. My directories are grouped first, then all my files. So alias, what we're about to set up on our personal computers so that you don't have to do SSH, your name at, or a dot, yeah. So these are little shortcuts and they're handy for using the HPC in an everyday kind of fashion. We're never going to write code with them because we cannot assume that any other computer will have these same shortcuts. They're just set up on this system. You're going to set some up just for your system on your laptop. Oh, I've changed mine. Okay. But when you do it, what do you get? Let's see. Oh, I guess you only have records, so it doesn't matter. Okay. All right, I've also got a couple aliases that I've added down and up. So we're gonna put these on your computer and we're gonna put them on your HPC as well. But right now, I want you to exit. Superpowers are gone. You're back to a boring old crappy laptop. Okay. Type in alias. Now this is your laptop's alias. I got a bunch of stuff you probably don't have. Nothing? You got a few. Oh, so you've already got LL. Awesome. Anyone else have stuff?
I have 3 things.
Okay.
LL, LS, and Wing It.
Wing it? Wing it. Wing it. Wimpty Winget. So that's a Windows thing I've never ever heard of before, but you've got Wing it, or it's probably Winget. Okay. Neat. Well, let's make an alias. And the way to do that is alias LL equals, no spaces between the thing on the left and the thing on the right. And then in quotes, we do single or double quotes here. So I'll do single to match what I've got up here. What would you like LL to actually mean? So anytime you type LL and enter, it's gonna execute everything that's within these quotes.
This
Oh.
was the question, should I be in my biocomputing? Like, professor right now, or just like.
Doesn't matter.
Doesn't matter.
Yeah.
Let's do the aliases, okay.
Yeah. Well, it's gonna be LS, but then we're gonna give it some flags. Definitely an L flag. Because list long is what LL stands for. What else?
Okay.
Okay, so we want to see hidden files usually. I like putting the H in there, so they're human readable file sizes. The brain doesn't understand 64-bit byte notation very well. That might be enough. So end your quote and hit enter. Congratulations, you just made an alias. So now try LL on the computer. Cool. Okay, now type exit and hit enter again. It's gone. Better open my terminal again. You Windows people, that'll be git bash. So open her back up. Try LL.
It's not found.
Command not found. Just like if I tried II. Command not found. Oh, apparently there is something called II. I'm not going to install that. I have no idea what it is. Okay. So what's happened? You made an alias. You closed your terminal. You reopened it. Alias no longer there. It never will, ever. You have to type in alias every time you open your terminal, which is very lame. So we're going to get around that. There is no way to have it persist constantly from session to session, but we can trick it into doing so. If you're probably in your home directory now because you just restarted. Frozen. Control C. Get out of jail free. Nancy on a minute. I think I just say exit the window. Yeah, it's
like.
okay. Now you're back in your MacBook. And were you able to make the aliens before? Yes,
Something so popped up.
that's because you already had it. Yeah. For those of us unlucky, who don't have it already saved in there, we can trick our terminal into creating aliases for us every time we start it up. And that's one of these hidden files. Since I'm in my home directory, I'll do ls-a, and I'm gonna see everything that's in my home. It's probably a bunch of crap. But one of those hidden files I have is .bashrc. If you're on a Mac, it might be .zshrc. You have one of those too. Who's got zshrc? All the Mac people.
What is that?
Z shell.
It's just a different show.
It's a different shell. So we're learning bash in here. Z shell works with all bash stuff, but they've added some things like different types of autocomplete. They've also added, it tries to understand and tell the difference if you miscapitalize something. This is typically considered a very bad move. And so no way are you ever going to find an HPC that runs on Z shell. It's just a Mac thing. It's a design choice that happened 2 years ago and caused some uproar because it broke a lot of code. It's fine. You can use Z shell on your Mac. No problem with everything that we do in this class. But all that means is that your magic file is going to be ZSHRC, not bash RC. Oh, you can't enter it, right? Because you're trying to say dot bash RC, hello, run dot bash RC. And it's like, that's not a command. I just want to see that you can have it. So ls-a will show me which one you've got. So we can scroll up. There they are. And you've got dot bash history, but not the dot bash RC.
Yes.
Same for you. Windows thing. Are you loving this? All these different computers? This is why we're mostly going to be working in the HPC, so we all have the same computer. But what it means is that your computers all have different architectures. They're running sometimes different shells. The Windows people are actually using a fake version of Bash called Git Bash, which can only be run as a program in Windows because Windows doesn't have shell. Windows tried to make their own shell. It's called PowerShell. They did a piss poor job. It doesn't work. So Mac people, if you've updated in the past 2 years, you're running Z shell. And then anyone on Linux is running Bash. With the exception of a few weirdos out there in astronomy, we do this TCH, SH. That's available also if you'd like to write C or Fortran code, but it's very uncommon that people use that. So we're learning Bash. It's the same as Z shell. It's the same as Git Bash that the Windows people have. That magic file there, .bash RC, the RC stands for run command. And essentially, every time you open up your shell, that file gets run from top to bottom, and every command that's in there gets run. This is a no matter what kind of situation. So if you put in bad commands, they will get run every time you open your shell. So imagine if every time you open your shell, it deletes your home. You could do that. You could absolutely sabotage your frenemies. Grad school, this was a big thing. People editing each other's .bash RC files. You leave the computer open to like write insults every time you. Okay, so yeah, we're gonna do that. We are absolutely doing that. But if you're on a Mac, you're going to be editing your .zshrc. If you're on any other computer, it's .bash RC. And so we're going to edit it with Nano. And let's do this. Let's give it the actual path to it, which is tilde home. That's our shortcut for home. .bash RC. Mac people, that'll be ZSHRC. Now, you Windows people that don't actually have a .bash RC, you're creating it right now. Okay. So nano.bash RC. It's going to open up here. Okay. Windows folks, it'll be an empty file. Everyone else, what have you got on your V show? Conda initial. Oh, that's why next to all of your like usernames down at the bottom, it says base next to it. It's because you have let Conda take over your .bash RC. We'll fix that for you later in the class, but this is very bad. It makes things really confusing because you've basically, Conda's great. Those of you who use Python, like Conda's awesome, and we're going to be using it a lot. So it's also a bug that deliberately, when you say conda init, that one time you did for that class back in the day, conda init, it rewrote your .bash RC or your Z shell to where it's always on and always watching you, and it has started rewriting your environment variables. There's never a case when we actually want this. It really pisses me off that teachers like do, and it's much easier just to say conda init because they don't care about your computer or your future. We'll fix it. Okay.
Mine is. I don't know how to show you, but it's like a weird, because every time I open my terminal, it says the same thing. It says this. But it hasn't affected anything, but it's also on here.
Oh, go up. Let me see it. It says
Like every time.
new bin.
Yeah,
Okay, because that's being run in your .bash RC.
so it's fine that it says,
Yeah,
okay.
it's just you've got a bad command in your .c sha RC.
Okay.
Anything we put in here gets run every time we open it. So, for instance, I've got hist size equals 1000. Hist file size equals 2000. That's my history. So when I type the word history in my terminal, it shows me my last 1000 commands that I've just set this variable. Okay. Anything we put in here gets run. Now I'm not going to scroll all the way down in mine because somewhere in here I do have like API keys and passwords saved. And this is being recorded. So I'm going to add stuff up here at the top. And what I'm going to add is my alias command. Alias ll equals yeah, ls ahl whatever.
This is, it's just a question, but is there ever a case you'll put spaces between like the equal sign or like the?
No, that's a bash thing.
Yeah,
If you're setting a variable, and that's how you do it in bash or an alias or whatever, spaces like freak it out.
okay,
Yeah,
so no spaces between.
no spaces between the left and right side of variable setting. That equal sign. I know, I'm used to R, that's like my native language, and you can put tabs and spaces or new lines, it doesn't matter. Python makes you tab things just a certain way, it kind of bugs me, but I get it. Here, they hate spaces. New language. So that's one alias. I would recommend an alias that's U, means up. CD space ... Right, so that takes us up one, and then I'm gonna put a semicolon, which means new command. What else would you like to do when you go back up one? If you're just kind of browsing through your terminal, you're like, oh, up. Clear. Let's clear the screen. Then new command. Let's go ahead and list everything. LL. Yes.
So do the semicolons into this like kind of just like separate different like steps or like run
It's like
lines
hitting
of code
enter.
pretty much?
Yeah,
Okay.
lines of code, yeah.
So what is the clear that I already thought we would do it? Or that you,
It would go back one directory
Mhm.
to the parent directory where you were. It would clear your screen, getting rid of all the garbage on there. And then it would list everything long ways with all the files human readable.
Okay.
So we got an alias inside of the alias here, and that's totally fine. And then we can do a down alias down equals. I want to go back to the last directory I was at. CD minus. That's how you go back. So no matter where you were, it takes you to your previous spot. Clear. LL. I spelled that alas. That would totally fail. And then let's go ahead and add an insult, echo. You can remove that later if you want, just by editing this file, but I'm gonna keep it in. I think it's good to remind myself. Okay, I need to save this. How do I do that in Nano? Control O. And then it's gonna ask, do you really want to save this? Root home gzon.bash.rc. It could be .zsha.rc or something for you Mac people. Yep. And then get out of here. Control X. Okay. Now I've edited that file, but it hasn't actually been run because I haven't opened my terminal. And there's a couple ways you can do this. You can just close your terminal and reopen it. Or if you have bash, you can say exec bash. The safe way is just close your terminal and reopen it. Which is what I'm gonna do. Exit. Reopen. Oh, look at that. We'll never be good at this. Okay, well, now if you type in alias, you should see your LL and your up and down. If you don't, we got a problem. You don't see it. Okay, we got a problem. So let's see. Yeah. Let's look at that file again. So nano, your dot z sh rc, zshrc. Okay, you've got your conda stuff, but I don't see your alias. So it means you didn't save it, or you go ahead and hit Control X to get out of here. And then let's do the up key. I want to see your last commands that you wrote. Ah, there you go. You edited a file called .bashrc, but your Mac is actually running .zshrc. So that's okay. So yeah, I'm gonna show you, we can look at the contents of that by cat. So CAT marks it up and hit enter. So you can just copy all that and paste it into that home.zshrc.
So,
And then right at the top or right at the bottom after the on the initialize stuff, you just paste it in. Now Control O, enter Control X. Permission denied. You don't have permission to change your own computer. It's like a. I'm curious. Like, is it a rental or something? Okay, that's all right. Just Control X. I'm gonna try to save this. Okay. So we're gonna try something here. The computer's password. So your computer has it locked down. Okay, now paste it in. And Control O, Control O, enter, Control X, done. Okay. If you get that weird permission thing on your computer, I did not expect. It's good. So the magic secret word was Sudo nano this file. Any guesses? It's super user do. Basically saying like, I am an admin, let me do this, and ask for your password. And that's your computer password, not your like let me know password. Be ready for that one. You will never ever get to use it on the HPC though, because you're not the admin there. So now close it, reopen it, and type alias, and you should see your LL up and down. Okay. One more. Let's redo that. Let's go back in. Do the sudo this time. It won't ask for your password again unless it's been 5 minutes or more. I'm gonna nano my home dot bash rc, Mac people, that's VSHRC. Home dot max alias Bora equals SSH. She's on at, oh crap, I forget. Cyclone. That, okay, copy that. Please don't literally type G's on in yours. You could try, but you don't have my password. Okay, save the file, exit. Control O, enter, Control X, and then exit. Reopen your terminal. You'll never be good at this. Okay. Now you should just be able to type Bora. You've got an alias that's running you straight in, it's asking for your password. And we're back. Okay. This has been your introduction to .bash rc. This is a magic file. And now you Mac people do LSA. You're not going to see .zsh rc anymore. You're going to see .bash rc. How come?
It's bash.
It's bash and APC, and that's what we're dealing with right now. Your terminal is channeling the login node of Bora, and they run bash. By default, they run TC shell, but I told them that we're better than that. Give you all bash, and so they did. Well, look inside that .bash rc. You've got editing privileges on that. If you want to check for sure, try LL and look over to privileges. You are, the first character is telling you whether it's a link or a directory, or if there's nothing, it means it's a file. Next three, read, write, execute. You should see an RW. That means you, the owner of that file, can read and write. So write is you can make changes.
So it's initializing new like bash RC for everyone.
Yes. And if I want to look at it, I can just say nano.bash rc. Don't change this stuff unless you know what you're doing. They put that for a reason, right? They've had problems. Okay, here's revision histories. The last time it was updated was 2012. Been a hot minute. The following options can be modified based on just scrolling down with my arrow key. We've got all this stuff in there. It's got some aliases that they've put in for us. Enable color support. More LS aliases. This is where I've added my up and down. You guys don't have those, right? Whole bunch of stuff. Okay. So go ahead and put any aliases you want in there that you want to be able to use in the APC. So up and down might be handy. You can see that we've added a couple things here. The dash group dash directories dash first. I like that because it puts all your directories up top, and that's usually what you want to see as you're navigating through. I didn't do that before because Macs don't like that. The C shell can't handle that command. Here, we'll again. I don't care if you do it not. Personal preference. People have run Conda stuff before. In your .c RC, you probably had a Conda init section. It's like right at the top. Hopefully you don't see that in this one. Hopefully we never do.
So I just delete that one.
Let's not yet. Yes, the answer is essentially yeah, we're gonna delete it, but I wanna make sure that it doesn't like affect any other classes you're taking before we do that.
Yeah.
Okay.
I don't think it is.
We'll just make sure.
Yeah.
I'm still like new here. I don't want to piss off anybody in data science or whatever. I'll go next year.
What's the LS dash CF?
I don't know. I can show you how to find out though. Does anyone still need this up here? Yeah, okay, no problem. Yeah, the capital C and F. Good. Okay, so we're so I'm just gonna control X, get out of here. I haven't made any changes. LS dash dash L. Sparks up the entire help. So when in doubt, and you're like, I wonder what flags I can add. This is where you find them. Okay, so it's saying that you can either put a dash A or dash dash all, and it will not ignore entry starting with dot, show hidden files. Capital A is almost all. So go ahead and show all the dot files, but ignore the implied dot and dot dot. So here and parent. F, classify. Append indicator to entries. I would have to Google to know exactly what that means. Then the C lists entries by columns, okay. That's what CF is doing. And so for them, that was just L. There it is. But giving it to me in columns can be handy. Working with columns is nice, and that at is only on the things that are symlinks. I'm guessing at means a symlink. I definitely prefer looking at it long ways myself. Because I can see all the file permissions. My hidden stuff, and it's just my directories up top. Okay. Next class period, we're going to bring in biocomputing from your computer to the HPC. We're going to do that 3 different ways, showing you how to move files back and forth. But your assignment for homework is to practice logging in and out and just getting a feel for being comfortable on the HPC and editing that .bashrc file on there. Find a couple other aliases that you think might be handy. Add. GPT's got good suggestions on those. Google's good. What are some useful aliases? And add them to that .bashrc. Because I want you not being afraid of it. I made it kind of scary where it's like, if you do put bad code there, it will be run every time. That's not great, but we can fix it if that does happen. So don't be afraid. This is your run command file. I want you to be comfy knowing where it is and how to edit it. The other thing to do is to explore the different folders that you got available, like data 10. Go ahead and put some fake files in there. Why not? So your homework is simple. Just dick around with this until you're comfy with it. We'll do transferring files next class. Also, the first quiz. Stick around for a few minutes if anyone's got questions. If you want out of here, just type exit and then you're back to your computer.
So we just want to send it to like done before awesome, which is okay.
No, you won't be ready.
Obviously don't know.
I mean, go ahead and start it, but like you'll probably hit some roadblocks. So look over assignment 2, but let's not have it due until next Thursday, a week from now. Yeah, you would just be sad if you tried it right now.
Yeah, I'll protect my, yeah.
After next class, you'll be good.